Hello, April18, Mr. Lawrence here with your flipped lesson. It's Wednesday, April 18th, and I just wanted to review a little bit of probability. Remember, you've got your tests coming up. Some of you have been pretty lazy on your homework. Please don't be surprised when you get the results, okay? You're choosing to not do your work, you're not going to do well. I don't know what else to tell you, all right? Especially some of you in my 8th period class, really not giving your best effort. You're going to get poor grades. All right, now I want to review the words like and. And means to, hopefully you're saying, multiply. You are correct. And does mean to multiply. Now, looks like part of my thing is covered up there, but that's okay. All right, and means to multiply, and it also implies that more than one thing has to happen. Okay, so if I'm drawing cards from a deck, and there's an and in there, I'm drawing more than one card, okay? Nora has two possibilities. It's going to mean to add, except you got to ask yourself twice. Can the events happen at the same time? If they cannot, you are simply just going to add. That's all you're going to do. You're just going to add. You're going to find the probability of both events. You're going to add them together. And or is implying that only one event is happening in many cases. All right. Now, if they can happen at the same time, that's the one that's a little more complex. And that's where you're only going to have one event, but, one draw, but you have to add them together. You have to multiply the two probabilities together, and then you have to subtract them. Okay, so that's just a quick review. That should seem very familiar to you. But in case it's not, we will do some practice problems here. And let me see. Here I have a bag of very colorful jelly beans. I have circles, stars, rainbow kind of things, and flowers. All right. I want to know the probability of drawing out a flower and then a rainbow. So you're noticing that I have to draw two jelly beans. Hopefully you have a question going in your mind. Hopefully you're just not starting to write. Hopefully you're saying, are we putting the first jelly bean back? Well, let's see here. It looks like we are putting the first jelly bean back because it's sold with replacement. So we're going to put it back in. We're not going to eat it. And we're going to put it back. So what's the probability of getting a flower jelly bean out of my little bag up here? Well, I see 4 flowers, right? And let me see, how many total jelly beans here? It looks like there's 5 there. 5 are the colored ones. And then there's 4 flowers, so I'm up to 9. And then 6 more makes 15. So the probability of getting a flower one is 4/15. Now, I put the flower one back in. I try to draw again. By the way, and means to multiply, right? Okay, and now I got to get this rainbow colored kind of guy. And it looks like there's 5 of those in the bag, and there's still 15. All right, I'm going to multiply these together, but before I do so, I'm going to simplify. I'm going to turn 5/15 into 1/3. I think that's as far as it'll simplify. Do 4 times 1, I'm going to get 4. 15 times 3, and I'm going to get 45. And it looks like the probability of reaching into this bag, getting a flower jelly bean, putting it back, and then reaching in and grabbing this rainbow colored one is 4 out of 45, which means every 45 times I do this, I would expect there to be 4 outcomes. Okay, 4 times that this outcome happened. Now let's take a look at this one. It looks like the same problem, but it's not. This time I'm going to get a rainbow, a star, and then another rainbow. And again, you need to know, there's actually 3 events going on here, but are we putting the jelly beans back? Let's see. No, we are not. This is without replacement. So I'm going to come up here and see the probability of getting a rainbow jelly bean. And from the last problem, I know it's 5 out of 15. 5 out of 15, I know for a fact it's going to simplify to 1. Oh, silly goose. 1/3. I started to write 1/13. 1/3. And means to multiply. Now, remember, this was 5 out of 15. Okay? Since I'm multiplying, I went ahead and simplified it. Now, one of these rainbow ones is no longer in the bag because, oops, that's 2 of them. Let's see if I got one separated. I guess I don't. I can ungroup them, and now I can take one of them out. There we go. He's no longer in the bag because we ate him, right? Okay, so now to get a star, it looks like there's 3 stars in there. 3 stars. But there are only 14 jelly beans left in the bag. So the probability of getting the star one is 3/14. Okay, that doesn't simplify by itself, but I'm going to mark down multiplication for the and now I'm going to go back to my my rainbows. Now remember, one of these stars is no longer in the bag. It looks like I have 4 rainbow colored ones, and I think I would be down to 13 total jelly beans. So this is going to be 4/13. I'm going to move this without replacement stuff. It's kind of in my way. We know it's without replacement. All right, now I'm going to do a little more simplifying before I multiply. I see that 3 and a 3 can simplify. And then that goes into there twice, and 2 goes into there 7 times. And I'm simplified as far as I can go. Now I can multiply. 1 times 1 times 2 is 2. 1 times 7 is 7. 7 times 13, I think, is 91. All right, the probability of this happening in this order is 2 out of 91. Now let's come down to this one here. Oh, by the way, each problem we want to assume that we start with our full bag of jelly beans. Okay, so we're back. The regular jelly beans are back in, and now we're on the probability of getting a smiley or a flower. Well, I'm going to ask myself, is it possible? Remember, or means only one draw. Is it possible to reach in and grab a smiley and a flower and only take out 1 jelly bean? Why, no, it's not. So this will be a simple one. All I'll have to do is add these 2 fractions together. All right, the probability of getting a smiley jelly bean is 3 out of 15. Now, you might have the impulse to simplify that. I'm not going to, because I know I'm going to add, and I might lose a common denominator if I simplify. Okay, so I'm going to keep it like that. Now I need the probability of getting a flower. I don't have to worry about with or without replacement because I'm only taking 1 jelly bean out. All right, so no jelly bean has been removed from the bag yet. I'll do the probability of a flower, and then I'll add the 2 probabilities together. And I think there were, well, let me go back and check. It looks like there's 4 flowers and 15 total jelly beans. And sure enough, there are 7, our probability to be 7 out of 15, and that does not simplify. So every 15 times I do it, I would expect to get either a smiley or a flower 7 of those 15 times. It's almost 50% chance, almost. Okay, one more example I want to look at. Let me see how the time's going. Oh, this is good. This is going to be a nice short video. Nice review for you. All right, I've got a standard deck of cards, 52 cards. I guess I should have an S on the end of there. And we've got 4 suits, hearts, diamonds, clubs, and spades. Each suit has the following numbers, 2 through 10, has the following face cards, Jack, Queen, King, and then aces. All right, and I want to know the probability of getting a face card or a number. Well, let's see here. The probability of getting a face card is, looks like there's 3 face cards, but there's 3 in every suit, right? So that is going to be 12. 3 times 4 is 12 out of 52. The or means to add. It also means only 1 card is being drawn. So I am not going to do with or without replacement. I don't need to worry about that. Now the probability of getting a number. How many numbers are there from 2 to 10? Now before you say 8, stop and think about it. I think there are 1, 2, 3, 4, 5, 6, 7, 8, 9. You can't just subtract. You can't just go 10 minus 2 is 8. You have to add 1 because we're not counting the spaces between the numbers. We're counting the actual numbers. You have to include the endpoints. If you think about it, those of you that thought the answer was 8, how many numbers are there from 1 to 10? There's not 9. There's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 numbers. If you just subtract 10 minus 1, you only get 9. So that thought process is flawed. All right, so if you're going to do the subtraction trick, you have to add 1 at the end. All right, now how many numbered cards are there? There are 8. No, there are 9, like we just said. And there are a total of, oops, there aren't 9, because there's 9 in each suit. So 9 times 4 is 36. And there are 52 total cards. And so I'm going to go ahead and add these together, and I'm going to get 48 out of 52. And I'm going to divide by 4, and I'm going to get 12/13. So it is very likely that that will happen. All right. One way you could have thought about it, what's the probability of getting an ace? Because we counted everything but the aces, right? Well, the probability of getting an ace is 4 out of 52, right? Okay. Now, how many total cards are in the deck? Well, 52 out of 52. Well, watch this. 52 minus 4, 48 out of 52. All I did was subtract off the aces, and look, I get the same answer. Okay. If I simplify this, I get 1/13, right? Well, if I take the total deck, that'd be 13/13, and I subtract, I'm going to get 12/13. Just another way to think about it. Notice it's the same answer. Okay, so I really liked how Mr. Underhill was giving a different way to do it in 7th period, and Gary had a different idea, and I had a different idea. It shows intelligence that you're coming up with different ways to do the same problem. So you could think about the probability of how to get an ace, because that's easier to compute, and then taking that way, only because we accounted for all the other cards. All right, now let me see, do I have one more example here? No, but I do need one more example, so I'm going to go back here, and I need to know the probability of getting a number or a heart. Okay. All right. Now, is it possible to get a number that is also a heart? Yeah, I could draw the 2 of hearts. That would count on the number side. It would also count as heart side. So this is going to be those where the or is going to mean to add, but I'm going to have to subtract and multiply. And what's going to go here and here and here and here are going to be the fractions for number, for heart, for number, and then again for heart. Okay? So the probability of getting a number on one draw, we said there were 9 numbers, right? 4 suits, 9 numbers in 4 suits would be 36 out of 52. 36 out of 52. Okay. What's the probability of getting a heart? Well, there are 13 hearts out of the 52 cards, right? Okay, so then I'm going to do the 36 for 52, and I'm going to multiply that by 13 over 52. You see how I just used the same 2 fractions? All right, I'm going to go ahead and add over here, and I'm going to get 36. It's going to be 49 out of 52. And now I might do a little simplification over here. I'll do it in blue. All right, I know 13/52 is going to turn into 1/4, right? I know this, divided by 4, I'm going to get 9. That divided by 4 is going to be 13. Yeah, I think I like that. I think I like that a lot. 9/13, right? Okay. So if I multiply 9 times 1, I get 9. And if I multiply 13 times 4, I get 52. So now all I have to do is subtract, and I will get an answer of 40/52, which does simplify. I know they divide by 4, and I will get 10/13. And there you go. And that's your lesson for tonight. Hopefully you're becoming experts at this. Mr. Lawrence signing off. We will see you tomorrow. Remember, if you'd like to come up for lunch, you sure can. Have a good night, everybody.